Hello and welcome. I am Daniel, a current master's student at Cal Poly Pomona, working with Dr. Rakesh Mogul and NASA/JPL in the area of planetary protection, as it relates to bacterial forward contamination. Today I'm going to explain and go over the protocol for the bacterial growth curve of Acinetobacter radioresistens 50B1 using a diluted defined metal medium. Hope you enjoy.
The growth curve process begins with creating a Preknock. This first requires an LB plate with single colonies of your bacteria that you need to prepare beforehand. You will also need a screw cap test tube used to hold the diluted defined metal media. For this, we will add 2 milliliters of our 0.2x M9 solution, as shown. After, we add 10 microliters of NTA master metal mix, as shown. Make sure to add within the solution due to the low volume. Now, scoop 1 colony of the bacteria from the LB plate. Make sure the bacteria goes into the medium by shaking the loop vigorously, as shown. Then quickly vortex the media with bacteria in it. Lastly, add 2.4 microliters of 95% ethanol. Make sure to add within the solution due to small volume. Finally, parafilm the cap so no ethanol is evaporated out of test tube. And you have just made the Preknock and add to the incubator. Now, let the Preknock incubate at 28 degrees Celsius, shaking at 200 RPMs for roughly 10 hours or until the optical density reaches 0.4 or higher. 10 hours has passed and it is time to check our Preknock optical density. When checking the optical density, make sure to vortex the solution and use a chem wipe to clean the test tube. Also, have the spectrophotometer properly blinked. Make sure to note down the optical density for future reference. We can now start creating our Inoculate solution. To begin, we will start just like we did with the Preknock by adding 2 milliliters of the 0.2x M9 solution into the screw cap test tube as shown. Then we will add 10 microliters of NTA master metal mix. As previously done, we will make sure to add within the solution. We now vortex the Preknock test tube and extract 20 microliters of solution. We add this 20 microliters to our new Inoculate solution. Again, making sure we add within the solution. We quickly vortex the Inoculate. And finally, add 2.4 microliters of 95% ethanol to the Inoculate. Like always, we make sure to add within the solution. Now, parafilm the test tube. We now check the optical density, first noting down the time, quickly vortexing the solution, chem wiping the test tube, and finally noting down the optical density. Now let the inoculate incubate at 28 degrees Celsius, shaking at 200 RPMs for 1 hour. Then check the optical density as shown before using the spectrophometer. Make sure to note the optical density and minutes that has passed when checking. It should be 60 minutes. After the initial 1 hour optical density check, make sure to check the OD every 30 minutes until the OD levels out. Again, make sure to note the OD and minutes that have passed each time you check. When creating a growth curve, you will need to use Excel. To begin, create a table that looks similar to the one shown. The table will need to have one column for the time mark, one column for the time, and finally, one column for the OD values. Once this table is set up, you can begin plugging in your OD values after you check them. Here's an example of how the growth curve and inoculate should look like. In the beginning, the inoculate is clear at time mark 0. Later, as the OD increases, the inoculate will get darker, as shown. You will also start to see the growth curve starting to form. Make sure to keep checking your inoculate OD value until it peaks. Finally, the growth curve is done when the optical density levels or even starts to dip as shown. You have just completed the growth curve.